and about the land on the surface. So I think that is, yeah, that's all I have.
Is it actually possible to build a base on the surface of the Moon, given the amount of radiation that's around?
Yeah, you do have to, radiation, that's another advantage of why the people look at the lava tubes, because you're protected from radiation environment. The Earth is protected by magnetic fields from solar radiation, but if you're on the Moon, one thing you would like to do is to, if you have water and food storage, you'd like to wrap that around the outside of the lunar base structure. Because if you have a meter of water, then that protects you from the radiation. Yeah?
How could robots get on the Moon? How?
Yeah. So, like the one that may launch this year from New Zealand. Right now, the robot's being built in Florida, and it'll be shipped over to New Zealand and put on a rocket. And the rocket goes up, goes into Earth orbit, and goes out towards the Moon. It takes 3 days to get out to the Moon, and then it goes in orbit around the Moon, and then it fires its jets and descends, and in about 30 minutes it lands with landing legs on the Moon. And so there's Moon Express wants to be like Federal Express to the Moon. And so they have a whole series of people that want to send little packages to the Moon that way. So, but there's a lot of rovers. One thing that they were trying to do with the rovers on the Moon is they wanted to be able to land, take pictures, and move and take pictures, and so some robots were like rolling out, and other ones were like the whole vehicle would lift off like a helicopter and land again.
How did the Moon get into space?
How did the Moon get into space? Okay, that's a really good question.
That's a long one.
Yeah, it looks like one of the things I didn't mention is that the current theory about the origin of the Moon is that something in the early part of the solar system, big objects were running into each other all the time. And there was the proto-Earth. Before Earth, there was a planet-sized Earth-like object. And something about the size of Mars ran into it. And so I had this monster collision between these two planets. And part of it got spun off into this ring around the Earth, and that ring coalesced into the Moon. And so they used that to explain why the Moon is really made up as though it's like the crust of the Earth. It doesn't have much of a core at all, and so it's much lighter, less dense than the Earth is, and so you have so it looks like the Earth and Moon had a common origin, but it was a giant, violent event.
How come it's round then?
Well, I mean, with enough gravity, even when it's molten, especially, it'll settle down into pretty much round. Yeah.
Is lunar ice pure water ice, or does it contain other things as well?
It looks like it contains other things. It looks like comets would hit the Moon, and then for a while the atmosphere, the fragments of the comet would sort of float around gases around the Moon, and then they would, if they hit a really cold spot, they would freeze out. And so it's a mixture of water ice and then all sorts of other volatile compounds like you find in a comet. And there's one evidence that they had from this was they took an upper stage of the rocket that launched Lunar Reconnaissance Orbiter and ran it into one of these dark spots on the Moon. And a plume of water came up, but they also detected a bunch of other stuff. Thank you. Yeah.
I'm curious if the idea behind getting to the Moon is to treat the Moon as a gigantic resource that can be mined, or if it's actually to be respected as a thing of nature that we need to protect, or if there's a balance between those two somewhere.
Yeah, I think there's a balance because the question is, yeah, if you protecting the moon as its own, and in some sense I think of it as a scientific reserve because there's lots of studies and there's no evidence of anything living or no biosphere on the moon, and so it is sort of a dry, dead rock, 3 billion years old, but it has a lot of scientific interest, and so what you'd like to do is, make sure that your activity, if you're extracting resources, is limited. You're not, strip mining. You're not, ruining the landscape. You're preserving it for future study. But all these things, all these big ideas about massive activities around the moon and in space, they still only use 1 part in 1,000 or less of the surface, and so even the water ice, it's what you. So it's not. We don't see a case where we're actually, using up a resource on this. But you definitely want to preserve and protect these things for the future. And there's already an agreement to protect the Apollo landing sites as historical purposes. But there's lots of interesting scientific spots to check. And one of the first things they want to do with the lunar ice is before you make rocket fuel is to study what's in it and what it tells you about the comet history of the solar system.
Yeah, how are you going to do that when the resources up there, like the resources on the Earth, are finite? How do you even know how much of the stuff's up there for a start?
Yeah, I mean, that's why a lot of the mapping missions are trying to document what's up there, and it is a little tricky for the lunar ice one because that is a limited area, and so it's in comparison to the big areas of the moon that are more general, but it's but a lot of the motivation is to actually move industrial activities off of the planet and out of the biosphere and help protect the living biosphere on the Earth, and while you're using material that's on the dead rocks. So we'll see. Yeah, lots of us. Okay, here.
What's the balance between, with sending something up to the moon, what's the balance between having something that's environmentally stable, for example, like carbon emissions, but also fuel efficiency?
Yeah. Yeah, so you were talking about like the effects of on Earth of the rockets and things like that going to the moon. Is that part of it?
Yes.
Yeah. The rockets certainly, if you're standing next to a rocket, you think it's like the worst ecological thing you've ever seen, but actually it's the most of the effects are from they're very localized, and the actual, even for Elon's giant rockets, it's about the rocket like the Falcon Heavy uses as much jet fuel as a Airbus 380 flight, one flight, and so it uses it all up in 8 minutes, but it's equivalent to one Airbus 380 flight. So it's the carbon impact is about similar to like a small airport for these big rocket flights. It's for the New Zealand Rocket Lab Electron, you need 4 of those to add up to one 737 flight. So it's so that there are still issues to examine. Like you have to examine the effect on the ozone layer and stratosphere, and there's more impact there. But Rocket Lab and SpaceX are doing the right things as far as minimizing environmental impact.
Hi, I'm just going to quickly interject. We do have telescopes set up outside. Otherwise, you're still more than welcome to stay inside and ask questions. Thank you.
Okay. Let's see. There's a.
Me?
Yeah.
Why does Titans and Sphere rain methane?
I'm sorry, I didn't hear.
Why does Titan's atmosphere rain methane? It's a different.
Okay. Yeah. Titan is a big moon of Saturn, and it's big enough that it actually has an atmosphere that's as thick as the Earth. But it's really cold. It's far from the sun, and so it actually water ice. Water on Titan is actually like solid rock, solid concrete, but methane stays liquid, and so methane rains from the sky on Titan. It's the only moon that we know of that has an atmosphere.
Yeah, something that's baffled me is the moon is supposedly covered with a lot of dust, and one of your shots there showed that the rocket blowing up a big cloud of dust, but it's just very interesting. I would have expected that to be the case with almost anything. When we saw the, well, first of all, without an atmosphere, does that dust settle very quickly?
The dust, one thing that with the moon is that it's been sitting there for billions of years without any erosion or anything like that. And so but the only erosion happens is when little rocks, micrometeorites, hit the surface. And it fragments everything. And so it actually ends up with like meters of broken rocks and dust particles. Unfortunately, that dust is like, it's jagged, little, even down to the microscopic scale, it's not rounded, it's like little fragments of glass or something like that. And so so that was a big problem for the Apollo astronauts, because they would come in from the capsule covered in dust, and then the dust would jam up their equipment and things like that. And so that's some area that you're really going to have to manage that for a lunar base. You don't want that dust inside your living area. But everything with 1/6 gravity, everything goes 6 times slower. So if you kick up some dust, it'll make this little arc, and then it'll go 6 times slower and fall over.
It's actually slower to settle.
Yeah.
I would have thought without an atmosphere to suspend it.
Yeah. Everything goes in little orbits. In fact, when you because there's no atmosphere, when you open up a door of the spacecraft, the atmosphere comes flying out, and all the little atmosphere molecules act like little spaceships. They go bouncing over the moon like this, and so it's a very strange. It's like when you open the door, you temporarily create an atmosphere around you, and then it all goes bouncing over the horizon.
What seems strange was that when we saw the shots of the first landers on the moon, there's been no dust settled on them.
Yeah.
You would have expected the feet to be covered on dust.
Yeah. Now they
look clean.
Yeah. Typically, the lander, when coming down with their jets blasting the dust away, because the rocket jets are like these blowtorches, and so and they were that one I showed of the Apollo 12 landing like 100 meters away from the Surveyor spacecraft. When they came down to the Surveyor would have been blasted by little particles that had been blown up by the lunar module of the Apollo lander, and so they could see that the dust had really been shooting a long distance. And so that's one thing in that video. They wanted you wouldn't be really wanting to kick up that much dust. You'd want to land on a landing pad, and there's one idea of using microwaves to sinter the surface to make a smooth landing pad. Some of these other people, yeah.
Are you aware of any totally intractable problems that we might have in getting to the moon, or is it just a simple linear application of brain power? Are there any problems we just have no idea how to solve?
I think we don't know very much about living on the moon, and the big problem is surviving the lunar night, because it's all the Apollo missions survived, were only ran there during the day and ran away in a few days, and the recent Chinese robot that was sent, the first evidence of the first time that the sun set, it died quickly, and so it's a real challenge, because you have to maintain the heat on these things, or the electronics just freeze up, and everything else does too. And so the question is, can you land and in 2 weeks build yourself a habitat that you can survive in, or do you have to do it in stages and keep running away, come back the next day? Yeah, I'm sorry, I'm running off.
Do you know of any plans to build like off-seat parks to stationary elevator spaces or alternatives to it?
There are people that are looking at that, and carbon nanotubes look like they might be strong enough if you can. He's talking about the most energy efficient way to get into space is not use rockets, but to take the elevator. And so if you had an elevator that is literally 1 million stories tall, from the surface of the Earth out to geosynchronous orbit, which is 36,000 kilometers high, then you could just climb up this cable with this energy, and you'd use about $3 worth of electricity to go to orbit. But you need something that's stronger than diamond for 36,000 kilometers, and looks like carbon nanotubes might do it, but people are still have only grown carbon nanotubes a few centimeters so far.
Many years ago, I heard of a theory that the moon came from the Pacific Ocean because it's the same dimensions, and that something banged into the Earth and it was planetary. I don't know whether it's true, but
that was an early theory. That was around Apollo days, and because people were looking at that it's about the same, about the right size and shape, it's all, one thing is that there's been so many plates that move around, the oceans opening and closing and reforming and like that, if you trace it back 4 billion years ago, the Pacific Ocean wouldn't look like it does now. But there is an element of that theory that says that there was something big that hit and blew up part of the crust of the Earth, and that formed the moon. And so when you look at the moon, even though it's at least 35 times as old as New Zealand, in terms of for the surface of the moon, but you see all these impact craters that any one of which would have been like an extinction level impact on the Earth. And so back in the billions of years ago, there was a lot of violent impacts that were happening, and it's settled down a lot now, but we still have this risk of asteroids, and we have to keep monitoring this. And every night the robot telescopes are scanning the skies looking for risky asteroids.
Yeah. Are there storms on the moon like there are on like to Jupiter and whatnot?
No atmosphere, but there is space weather, and so there's blasts of radiation particles from the sun every once in a while with a solar flare or coronal mass ejection, and those increase the radiation on the surface of the moon.
Eric, thank you so much for that talk. It's been so interesting, and I just want to know if you could wave a wand and be part of any manned spaceflight parts or the ones coming up, would you choose an Apollo one, or would you choose one of the ones that's coming?
I think the ones coming up are going to be really exciting because we're so used to only things happening in space as being massive government activities, and I've worked with NASA plans for so long where they say we have 6 people on space station, and in 100 years we might have 7 people on space station, or something like that. And then Elon and Jeff Bezos come along and say, we're building rockets to carry 100 people at a time, and it's just a different level of activity. And I think so. I think it's going to be a real interesting events that happen, and I hope we guide it correctly And I think one I was going to show you was this is my little animation of the moment in time here where we go from the arrival of the Maori and the Pacific into New Zealand, the arrival, 60 years of New Zealand Antarctic operations, a couple months of launching into space, and then a future of going to the moon, Mars, and asteroids. And I think we're at a moment in time that is where all of the past history suddenly becomes alive and applied to the future in a way that becomes very direct. And so I think, like as soon as I started thinking about this, about the moon and Mars and asteroids, I started to go around and like in Virginia, I would study what they arrived with in their ships and what tools they brought and things like that. How did they do a settlement? And so, I'm now trying to talk to some of the Maori groups about trying to apply traditional knowledge to this future and hopefully do it right. So we'll see how that goes.
You said all this was going to cost trillions of dollars to put to establish the thing where we can live on up at the moon or whatever, or Mars or wherever. Where's all this money going to come from?
Well, that's why Elon thinks that you can get the price down to a human deciding to, just like a person deciding to move to New Zealand, that they could afford to move to Mars if they went to.
We can't even buy houses here.
That's why we have to make sure that we do things right. And so I think I'll be happy to answer questions, but I just wanted to let people have a chance to leave.
Is there anything